Welcome back from the break. Are you energetic, hyped up? You've had a pot of coffee? Ready for some action? Yeah? Okay. We're going to talk about something very, very serious next. Security. And not in a very theoretical and boring way. We're actually going to get our hands dirty. My name is Antti Rössi. I come from Helsinki, Finland. I'm a CTO and co-founder in a company called Jobilla. So we help companies hire, basically. That's what I do for a living. So I write a lot of software with Laravel and PHP, Vue.js, using Kubernetes, all kinds of cool technologies. But my passion that I focus on my free time a lot is information security. And that's actually one of the main reasons why I'm here today. Hopefully, going to be able to teach you something valuable. Now, I truly believe that the fate of our users is actually in our hands, as developers and admins, in my hands and in your hands. If we know how to keep our users safe and how to write secure software, many things are going to go well. However, if we don't, we're going to be up for a world of hurt. Because it's our responsibility, it's our job to make sure that our users are safe. So here's the deal. Learn to hack yourself first before someone else does. If you know the basics of hacking, you're not affected by the basics of hacking. It's that simple. So if you know what's out there, what you're facing, you know how to protect yourself and your users, obviously. Before we get into the actual first demonstrations, however, please understand this. Hacking, as a rule of thumb, is illegal. If you hack anyone else but your own machine, it's illegal. So don't do that. We're not here to learn techniques to attack your neighbor or your competing company. We're here to learn about how to make our customers and our users safe. So use this knowledge well. I'm not endorsing you to do something like something bad or malicious with it. So please respect that and behave like an adult, which you probably do. Well, one might ask then, okay, thank you. Where can I practice this then? If you're going to teach us some tricks that are potentially dangerous, where can I practice this if I can't just randomly attack systems around the web? That's a good question. I encourage you to download these examples that we're going to go through next. You can find them in GitHub. I'll be publishing a link there recently after this talk. It's already out in my GitHub. If you happen to know how to find me on GitHub with my name, for example, you can find it. You can clone it right now. You can look at it as we hack through these examples. If that's not enough for you, and you actually get interested in hacking, and you start to consider that, oh, maybe this is actually a really good complementary skill as a developer for me, I should learn more, you can navigate to Hack the Box. They have a nice free tier. There's a bunch of intentionally vulnerable services out there for you within a virtual private network that you can practice your skills on. It's free and it's legal. So if you want to learn more, go there, not out to the web. Let's start by looking at SQL injection next. There's also NoSQL injection, by the way, so NoSQL doesn't mean no problems in this context either, unfortunately. In SQL injection, attacker injects malicious SQL queries into some form of an input device. In this context, it's obviously going to be HTTP requests, since we're dealing with Laravel web application. If SQL injection attack works and succeeds, you usually get the whole database out from that hole. So these particular type of injection vulnerabilities are super, super dangerous. That's why we're looking at them today. Now, here's a very common example that you might have seen, or I hope you've seen. If you haven't, you probably won't ever forget this after today's talk. Don't pass in unsanitized variables into raw database queries. If you do, you most certainly are going to open up your application for a vulnerability like SQL injection. However, it's not that straightforward. that's not the only way how you can get into trouble. Certain edge cases are actually really, really hard to spot in code reviews. So just the fact that you're not using raw queries doesn't mean that you're safe from SQL injection. No, 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 it's not that. I wish it was that easy, but it's not. It's not. Good and bad news at the same time are that it's actually really easy to test for these kind of vulnerabilities if you have the proper tooling available. That's the good news. Now, the other side of the coin, however, is that if you don't know these tools, you don't know about these tools, and you don't test your own applications regularly, someone else one day might do. Bad things happen. Let me show you what I mean. So within the example project, we have a very simple API endpoint that returns you a list of events. Nothing fancy there, it's a basic JSON endpoint. It takes in a parameter name, parameter sort. So you can choose to sort by basically whatever column that object has. Very simple stuff. If you place a minus there in the beginning of the name, it reverses the order in which you're being sorting. Very common functionality, basically. Let's take the API endpoint URL and pass it to a tool called SQL map. So SQL map takes in the URL you want to test. We pass that in. To make our life a little bit easier, we tell it in beforehand that we're testing against MySQL. It's just that we don't have to perform all kinds of tests for other database engines. And the batch flag basically tells us, don't ask any questions, just go. Do what you can do, let's see what we can get out of it. Now SQL map starts to perform a massive amount of experiments and attacks and tests on this endpoint. This video is fast-forwarded a lot so that we don't sit here all evening. You can see there's actually hundreds of individual queries going out to that endpoint. And SQL map does the heavy lifting for us in this context. And soon, it's going to come back to us. And it's going to tell us the parameter sort is vulnerable to 3 different kinds of vulnerabilities, SQL injection vulnerabilities. Not going to go into those specifically, more in detail here. But OK, SQL map said that there's something going on. Something is wrong. There's a vulnerability. What does that mean then? What do you mean that there's a vulnerability? And this is usually where people's knowledge stops. You know that there might be something wrong. Maybe there is something wrong. What can I do with it? What can some attacker, some malicious person do with it? If we play around with the flags that SQL map takes in, let's switch the batch flag to, say, current DB. And let's see what we get out. The same process starts again. We don't have to start from scratch, thankfully. So we're basically checking the same queries and using that vulnerability and getting out the current database of the application. So you should be able to see the purple in the lower left corner of the screen there, hopefully. Can you actually read back there at all? Anything? Maybe? OK. OK, good. And the current database is Laracon Amsterdam that the application is using. OK, let's dig deeper. Like I said, we should be able to get out the whole database through this. What about the tables? Can we read the tables? So we switch in a tables flag, start the process again. It starts running. We see the tables. 4 tables in this database. Now you can probably already guess where we're heading with this. Oh, there's a users table. That's fabulous. Let's look what's in there. So we change in a table flag, say, from table users, dump me the content of the table. And it starts going. But look, we don't have to do anything. It's actually the tool doing all the heavy lifting for us. And one by one, it goes through the columns, it goes through the fields, and it dumps us the whole users table in console. And in file, of course. You can get it in multiple different formats, but it's pretty bad. It's pretty bad, don't you think? You can get everything out from that one parameter that was not sanitized properly. And you don't even need to write a single line of code. You just brew install SQL map, and you run it. Bam. And you got it. You should see your face right now. You're like, oh my God, what happened? OK, but that's SQL injection. Now, this is a bit of a curveball. Raise your hand if you've heard about object injection before. Ooh, surprisingly many hands. Maybe 10%? 10% of the crowd. We have roughly 800 people here attending, so okay. Actually, better than I expected. Better than I expected. So we're going to go through object injection attack next. It's an injection attack as well, like SQL injection, and we're going to go from far deserialization to remote code execution. Before we get there, however, just to make sure that everyone's on the same page about these terms and weird constructs that we're going to be using in here, stream wrappers in PHP provide us with a nice abstraction to work with different types of protocols, like you can see in there SSH2 or FTP. So they're an inbuilt construct of the language. We're going to be particularly interested in the far stream wrapper in this context. Now, far files, also known as PHP archives, are basically a single file bundles that contain a complete PHP application. Very similar to jar files or Java archives that you might have seen in Java, for example. Composer, when you download it, comes as a far bundle, for example. So probably everyone sitting in here, even if you don't know what far is, you've used PHP archives in your life without knowing that. It's a handy tool. The far stream wrapper lets us read PHP files from a PHP archive. It's as simple as that. Now, the object serialization part then. In object serialization, we turn an object or an instance of an object into a string, the binary format that's easily storable in database, or you can encrypt it, you can do whatever with it. It's actually a very, very handy mechanism. And you can also deserialize serialized objects and turn them back into objects from string format. Now, here's an example. Let's take this imaginary class logger that has a couple of attributes and a couple of methods in it. We new it up, and we print out the serialized version of the instance that we newed up. This is what we get. So we get a string. We get a weird-looking string with quotes and mustaches here and there. What on earth is happening? The string contains the class name. So what is the type of this object that we're looking at right now? Then it also contains all the attributes of the object, the attributes' names, their length, and their contents, basically. So based on this information, you're going to be able to hydrate that instance back to life, basically. You might have noticed that there are actually absolutely no methods included in serialized objects, which is actually security-wise an excellent move. So you can't just go and, let's say, overwrite the object's constructor and do whatever malicious activities you might in there. That's not cool, so that's good. That's good. And it's especially good since when you deserialize an object, now you have to understand this. Wherever you deserialize an object, it's injected into that particular scope. So it's basically, you inject an object in your application scope, wherever that deserialization process happens. And that's where the name object injection comes from. Surprise, surprise. Now here's the catch number one. Why this is dangerous, potentially dangerous. There are two magic methods that are called automatically. The wake-up method and the destruct method. Now, if you happen to find a piece of code that would look something like this, now this is you could say an overly exaggerated, simplified example, but if you could find a piece of code like this from your code, from some library, where you would have something suspicious either happening in the destruct method or in the wake-up method that would be affected and influenced by the object's attributes, something awkward might happen. So this is a representation of the same object. This is the parameter that goes into the shell exec in the object destructor method. Why not just change it? Put something else in there, and you end up in a very, very hairy situation where you have code execution on, you can do whatever you want on the machine. And this is actually, if you find a class like this is what we call gadgets in exploit development. So these are gadgets. Now here's the catch number 2. PHP archives can contain metadata in a serialized format. They don't have to, but they can. Now, any file operation that you perform in the archive will cause that metadata to deserialize. And it's deserialized and injected in the application scope where that file operation happened. Now, here's a bunch of PHP file methods that some of you have probably seen before. And I want to highlight a few from here because from developers' perspective, I never thought personally, like I've been writing PHP for 6 years, maybe 7 years soon, and I never thought that there would be anything potentially dangerous in calling file size, for example, with an unsanitized parameter. Like, what can you do with file size? It's not like an SQL query or anything. So if you don't know about this vulnerability, most certainly you don't know to look for these. You don't know that there's any risk involved. The catch number 3 is that the Farstream wrapper does not care what type of a file you give it, which is probably in some contexts handy. But in our case, what if we do something like this? We take an image file. We had a malicious archive in it. And then we call file size method on that image file with the stream wrapper, the Farstream wrapper. That's going to cause the object from the archive to be injected in the application scope. And that's when our gadget kicks in. You could do that. And we will do that next. We'll be using a tool called PHP GGC here. It's an open source tool that you can find from GitHub, and it's going to help us generate a suitable payload for this particular example. So we'll be using a Guzzle remote code execution gadget chain, basically. It's not an individual gadget, it's an actual chain of multiple gadgets. And it also has a very cool method that allows us to hide this gadget chain in a JPEG. Okay. Let's see how that happens. I'll be using a picture of my cat Monni here, since why not? He looks like a villain anyways. So there's Monni. It's a regular JPEG, nothing fancy there. We take that image and we pass it into PHP GGC. We get out another image, and we're telling PHP GGC that use the Guzzle RCE1 payload, and in the end of the gadget chain, finish with running a PHP function called passthrough and pass in an argument, who am I? Now, if this proof of concept works, and well, of course it works because I pre-recorded it, but you will see in a while how it works, and we'll get the output of the command, who am I, on the target machine when this exploit runs. So, now a funny detail. Mac can't actually open this image anymore for some reason, because it's tampered. It's pretty interesting. If you open it in Chrome, however, you'll see that, yeah, well, it actually opens just normally. It's the exact same image with plain eye. You can't see from the surface that it's been tampered with. It looks completely normal. If you go into it, however, and you look at the string content of this file, and you grep the word Guzzle with some context around it, you're going to see that, ooh, man, around these bytes, there's something else. There's actually serialized code in there. So that's our gadget chain. It's in the image. What we're going to do next is that we're going to post this image to our example application. So there's an endpoint that takes in a file. Nothing fancy there. And by the way, yes, it does validate the file properly. But there's really no way for you to know if there's a string in that image like that. You can't validate for that, and that's what makes it super dangerous, because it's not the problem in the file upload validation. Now, there's another endpoint. Well, let's run the call, and I'll show you then what it actually does. But it tells us certain details about this file. So you can see there's a file size coming back, which would maybe, if we go into the code, the example code, you can see that we're doing some kind of a file operation there with Laravel's file system. OK, that's interesting. That might be vulnerable, potentially. And if we go deeper into that method, we actually see it just calls file size. So nothing funky going on in there. That's what's actually happening in this endpoint. Now, let's replace the parameter, the file name, with the varstream wrapper and see what happens. The output looks different. Before the JSON output comes back from the server, you can see the output of the comment that we injected in our Gadget chain. The comment was, who am I? And the answer is data. So that's the web server's user that's currently running in this vulnerable application. So we got code execution. OK, through an image. Cool, OK. Well, what can we do with that? Code execution, what does that mean? Running who am I is not any sort of a hack, even though it's not cool. You wouldn't want anyone doing that on your servers. Let's open a reverse shell. So we're going to pass in a netcat command. And since this example is running in a sandboxed Docker container, we're going to call home to Docker localhost, basically, from the container using netcat. So netcat will open a TCP connection for us, and it will pipe a bash shell into that TCP connection. And that's how a reverse shell in a nutshell works. Before we can run that, however, we're going to have to start a listener, which we do in a little while. But let's upload that file first. So it's called reverse JPEG this time. It's the exact same image, nothing funky there. We get a success back. The image goes through. And then we're going to check the file details, which I typoed in this video. So let's try again. So it's actually file name, not file details. And we see that the file was uploaded successfully. It's there. We can see if the exploit works now. But like I mentioned, before we execute the exploit, we're going to have to open a listener on our machine. So we'll be using netcat for the listening part as well. We're listening on all interfaces, 0000 and port 1337. Then we open a new tab in Tmux so that we can work with multiple terminal sessions side by side. And we trigger the exploit. Very same thing that we did earlier. So we put in the varstream wrapper in the API call. And you can see the API call stays hanging because there's nothing coming. The netcat started. And now here's the funny part. You don't actually see anything in the listener's side. It looks empty. If you start writing commands, however, you see output. It's an actual shell session that we have opened to this machine now. That's why it's called a reverse shell. So you're listening for it. It calls back, dials back home. ET calls home, you know, anyone? And you have a shell. That silence is priceless. I love it. One more thing. OK, we got the data out. We got a shell access. What more can there be? What more can go south? We're already screwed. In privilege escalation, the attacker exploits a bug or a design flaw to gain access to resources that they normally would not have. A very common way to privilege escalate, or to escalate your privileges, I guess that's how you say it, is to find something that's running as super user on the machine and hijack that. Try to exploit the process without crashing it. And if you have something with root privileges, and you're able to hijack the process without crashing it, the privileges remain. And you don't ever need to know the admin password, but you can have admin shell, for example. Now, very few things for this specific reason should ever run as root on the machine, on your host machine, on your local machine, on any machine. This is the reason why people tell you don't run it as root, and you're always like, well, what can go wrong? I don't know. People talk about it, but... And especially, I'm the kind of a person that needs to actually know what can happen. I just don't believe if you tell me to do something and I don't understand it. Now, artisan scheduler should definitely not run as root, ever. Please, on your machines, don't do it. I used to do it for years, and that's why I'm using this example, because I didn't know. I just SSH'd onto a machine and set it up. And I was good. Nothing ever happened, though, so I only learned about this later. But I was like, oh, man, I'm glad nothing happened, because If you're running your scheduler as root, this is what might happen. So we're starting from the very same reverse shell scenario where we ended our previous demonstration in. We'll be wrapping this netcat reverse shell into Python's PTY to make it actually look like a shell. So we can perform some interactive comments down the track. Don't worry about what's happening right now. I have 4.5 minutes time. I can't explain everything, but we're basically configuring the reverse shell connection so that we can actually run interactive comments with it. Because like you saw, it doesn't look like a reverse shell, and it acts like a shell, but it's still a plain TCP connection. So we need to get all the zoom options right. We need to make sure that our current terminal is in sync with that TCP connection of the netcat. There we go. You noticed we could run comments like clear now. So we're going to go to the console kernel, which is the place where you operate your artisan scheduler from. We're going to go into the console kernel file with Vim. We're going to jump straight at it, start to modify it. Now in the schedule method, that's the place where you specify what commands from your application you want to run periodically. Basic stuff, you've probably heard of it. Now, there's probably something that you haven't heard about, and that's the fact that you can actually run something else there as well. It doesn't have to be your application commands. You can actually run shell commands. And there's something that maybe looks a little bit similar to the previous exploit. We're going to start a reverse shell from Artisan Scheduler. And now if you're connecting the dots in your head, you're like, OK, scheduler is running as root. If we start a netcat, that netcat is going to start as root. OK. Sounds suspicious. Let's open a listener again, to a different port this time, because we're already in a reverse shell in the other tab. Same stuff, different port. We save the scheduler file. We wait for scheduler to execute. It executes every minute. That's how Linux cron tab runs. Once again, we go back. We got a shell. But this time, it's a root shell. OK, what next? Like, what can we do to make sure this never happens to us? It's a horrible situation. If something like this happens to you in real life, it's not cool. Not cool. It can mean the end of your business. Seriously. Firstly, you have to validate everything. Everything. If you validated everything properly, none of this would ever happen. Neither one of the examples, 1 or 2, would have worked. Then the second thing is, you have to keep your software up to date. The gadget chain that we use, the Guzzle gadget chain, was patched a couple of months ago. It doesn't exist in the latest version, but if you're running a semi-late version, which is not the latest version, it's not the same thing. It still exists. So if you're running up-to-date software, you reduce the risk of getting hacked big time. Also, please do not run code in production that you don't understand. If you don't understand it, how can you evaluate is it secure or not? You can't. Don't do it. And don't give people or processes access that they don't actually need. Why would you run scheduler as root? It's not an admin process. Why would you? I did because I was lazy. I admit that, but now you know it. Don't do it. And learn to think like a hacker. Like I said, if you know what's out there, you know how your applications can be exploited, these methods don't work anymore. Once you've seen this talk, hopefully, you don't have these vulnerabilities anymore. That's why I'm here, hoping that I get the message through and I can help you. Because once you know about these, you're not automatically safe, but you can protect yourself. You qualify to protect yourself, and that's the goal here. Security is not a one-time effort. Please understand that. Security is an ongoing, infinite process. It's a habit. It's a mindset, not a task. And you have to focus on it every single day. That you either write code or you run code. Every day. And you've learned something cool, something scary now hopefully something useful. Use it well. Please understand that this power comes with a great responsibility, and also educate other people. The security of our users and ourselves is in our hands. It's our job. Let's take it seriously. Thank you.